Okay, hello students. So in today's video lecture, we will discuss about the two important topics related with the Pearson's coefficients of correlations and Spearman's rank correlation. Okay, so first of all, we'll see the first one, that is Carl Pearson. How to calculate this Carl Pearson coefficient of correlation. The problem is something like this: the values of x and y are given. First of all, to calculate this Carl Pearson coefficient, the final formula is this one. Okay, so here we have to calculate. We will see what are the unknown quantities here. So n is the total number of values that is given. So here it is 1, 2, 3, 4, 5, 6, 7. So n is equal to 7. Okay, now this is summation xy. So we have to calculate the product of x and y, and then we have to take the summation xy. So that is xy. This 1 upon n, that is related with only the summation xy. Okay, so then we have to find out this x bar and y bar. Okay, so that we will calculate from the summation of x divided by total number of values of x. So here this is x bar. Y bar, it is calculated from the summation of y divided by the total number of y values, that is also 7. So we'll get here x bar and y bar y values. So that will come here. This is 60 and 68. So that values comes here. Summation xy value, that is 29464 divided by 7. So 1 upon n, that is related with only summation xy. Then at the bottom we have 1 upon n summation x square. So summation x is equal to summation x summation x square. So that is equal to x square. So we have to take the square of the x, and the summation x square, that comes out to be 28096. So here 28096 divided by n. Okay, summation x square. So we have already taken the square of the x, and then we have taken the summation. Similarly, we have to find out the x bar square. So x bar is equal to 60. So 60 square. Then again here we have to take the square of y values and the summation of that summation y square. So that comes out to be 34376. So here 34376 divided by n. Okay, it is not the we don't have to take the square of that. Already we have taken the square. So only directly that value we have to take here. Okay, and minus y bar square. So y bar means it is 68. So 68 square. Okay, so only these values you have to put in the formula, and then we have to find out the correlation coefficient. Okay, so in this problem we have to just remember the formula. This formula for calculation of Carr-Pearson the coefficient of correlation. Okay, we'll take the another example. We can take this example. So here also the x and y values are given. We have to find out the x square, y square, summation of x square, summation of y square, and summation of xy. So that value we will get here. We have to find out x bar and y bar because that is there in the formula. Okay, so that all values you have to put in the formula. Here directly they have separately calculated. You can remember the total formula like this formula. Okay, and then by putting all these values here, you can find out the values here. So that it comes out to be 0.624. So here directly they have given compute the Carr-Pearson's coefficient of correlation. So x values, y values are given. We require quantities like x square, y square, and the xy. Summation of these. Okay, the final formula is this one. Okay, the n value means the total number of values of x and y. So these x values are 1, 2, 3, 4, 5, 6, 7. So n is equal to 7 here. Okay, so 1 upon 7 summation xy. So it will come from here. Then the x bar and y bar, we have to take the summation of x divided by n. Summation y bar is equal to summation y divided by n. So that values comes here. We have to put the values here. Okay, in the numerator and denominator, and we have to find out the final values. Okay, so these problems are very simple. Just we have to remember the one formula here. Okay. Okay, so after that, we will discuss about the next the topic, that is the Spearman's rank correlation. Now this problem is based on the Spearman's rank correlation. Okay, so here we have to find out the rank. So find from the following data of the marks obtained by 8 students in computer networking and compiler design papers. So the marks for the 2 papers are given, and we have to find out the rank coefficient of correlation. Now whenever there is a rank coefficient of correlation, so that is by means of the Spearman's rank correlation. Okay, Now how to find out this? So we have to arrange this Cn and Cd, that becomes our x and y value. So this is x and y value, okay, in vertical form. So this is 15, 15, 20, 28 up to 80, and this is from 40 to 60. Now the next table is, that is the rank in Cn. So in here we have to find out the maximum marks that is obtained by the student. So 80, we have to give the ranks according to the decreasing order. So 80, so this is 1. Then the next one is 60, so that is 2. Then after that we have 43. Then this is 28, 4. After that we have 20, that is 5. 20. So now here you see this is 20, and these two values are repeated here. So okay, we have to give the ranks now. This is 5 and 6, okay, for this one, and then 15, 7, and last is the 12. So you have to give the ranks in the decreasing order. Okay, so we have given that rank, so you have to see which value is greater, and for that value we have to assign the rank. Similarly, we have to do it for the CD. So these are the CD values. We have to find out what is the maximum values in CD. So 60 is the maximum value, so this is 1. After that we have 50, okay, we have, then after that the 40, 30. Now here there are three values of the 30. So this is 30 here, 30 here, and 30 here. Okay, so whenever we have the same ranking, so we have denoted for 30 it is 5, then for this 30 it is 6, and for this 30 it is, I think it is a 7. Okay, it should be 7 here. Okay, 7. Uh, so then so this is 5, 6, and 7. Okay, so for CN there are the two same ranks, while for the city there are three same ranks are there. Okay, so for from the CN, for 20 and 20 we have to take the average. So the average of the rank, so that is 5 plus 6, so divided by 2, that is 5.5. Similarly for this 20 also, the average of the rank, so that is 5 plus 6, so that is equal to 5.5. Okay, now for this CD, we have ranks is equal to, actually, here this is 61, 62, 50. Actually this is 2 here. No, not this one. So in here, okay, so here this is, okay, so initially I have done with this one, not for that one. Okay, so this is for 5 and 6. Okay, so 5 and 6 for the CM, and then for CD we have 4, 5, and 6. So for average of these three ranks divided by 3, so it comes out to be 5. Okay, so this will give us the modified rank, that is value of xi and yi. Okay, so here this is 7. Instead of this 6, we have to use now 5.5 because of for the common rank, that is for the 20. Here this is 20. Then for this it is 4, because this is 4 is there, not 2. Here this is 4. Then this is 8. Okay, so 8 comes here, 3 comes here, 2 for 20. So this is 5.5 because the ranks are 5 and 6, average of that, and 1. Similarly for yi, we have to take this rank 3. Then for 30 we have to use the rank, average rank, that is 5. Here 5, here 5. Other ranks will remain same. Okay, so that will come here. After that we have to find out the values of di, that is the xi minus yi. 7 minus 3, that is 4. 5.5 minus 5, so 0.5. 4 minus 2, 8 minus 5, then 3 minus 7, 2 minus 8, 5.5 minus 5, 1 minus 1, that is it. Then we have to take the square of these values, di values. So, and we will to take the summation of this di square. That comes out to be 81.5. After that, we have to use, this is the formula for the calculation of Spearman's rank correlation. R is equal to 6 summation of di square, so that value is 81.5. 1 minus and n cube minus n. So how to calculate this value? So for this value, we have to take summation comes out in this form, 6 1 minus 6 di square. So di square it is 81.5. Now here we have to find out the ranks. See, for M1 there are two ranks. Okay, so m1 becomes 2 because there are two ranks are there, and for m2 there are three ranks. So m1 value is 2, that is for this 20. Okay, so these are the two ranks, so this is m1 value, and for the cd these are the three ranks, so that is the value of m2, so these three. Okay, so the final formula, it comes in the form of this. So m1 value is 2, 2 cube minus 2, and this 3, because there are three ranks are there for the 30 value. So for that value we have to take 3 here. Okay, so just remember this m1 value, that this is for the 20 value. Here two ranks, so this is 2, and for m2 we have the which value, that is 30. Okay, not 40, it is 30 value. And how much 30 values are there? 3. So we have to take m1 is equal to 2 and m2 is equal to 3. Okay, so number of the equal ranks. So here 2 and here 3, so that value we have put here, divided by 12, so that is the formula. And here n values, this is the n cube minus n. So what is the total count of n? So 1 2 3 4 5 6 7 and 8. So n values are 8, so n cube 8 cube minus 8. Okay, and then we have to find out the values of r. So here in this problem it comes out to be 0. Okay, so so this type of the problems are there. What we have to do whenever these the marks are given for a particular subject, we have to check the the ranks for the common marks, and then we have to calculate the average of that for the modified rank. Okay, when there are the common marks are there, we have to take the average of that. So here is 2020. uh, we have to we have to see which rank we have given, and then for that we have to take the average of that. So 5 and 6 are the rank for 2020. We have taken 5 plus 6 divided by 2. For cd there are three common values are there. We have to take the average of that three values. So 4, 5 and 6, the average you have to take. Other ranks will remain same. Then we have to take the difference of xi and minus xi minus yi, and then finally we have to take the square of that. That values you have to put it here. Okay. So this is the problem for the Spearman's rank correlation.